Yeah, here you go. Can't forget that. Every now and then I do forget about it. 23rd, the notes as well as are here, right? The updated notes. Yeah, 25th. Okay. I want to get the illustrations as well. And let's see the topics that we're covering, that we covered. There you go. For the students coming in. Okay, today, what we're going to do today? Today, 1 hour review of the material for the exam. And I also want to go through your spreadsheet, make sure everything is the way it's supposed to be, right? To be okay. We're going to do those two things. Okay, components. Oh, by the way, we are done with those two topics, components of a vector. I'm gonna keep it with the regular face here of the text. Okay, and nature of physics. This is, just read it by yourself. Okay, units. Every measurement in physics has a unit. Okay? But what's important too, right, is going back to what I mentioned before, right? Something like that is not in any book. So I have always to remind my students the building blocks of physics, right? The basic quantities. There are 7 quantities, but right now we are focusing only on those 3: length, times, and mass. And we are going to talk about the other ones as well. And both the quantities, the measurements, and the definitions, they have units, right? The units of length, position, displacement, the unit, and we denote that by a square bracket, okay, is equal to the unit of length is equal to the unit of position, which is equal to the unit of displacement. which is in SI system of units is the meter. For time, right? We can write it down as a square bracket of time is the seconds. For the mass, I'm gonna put it with a capital M to make it to differentiate it from the meter. Okay, it's gonna be the kilogram, and then you have, and then we have a combination of all these units. Velocity, right? Velocity, area, volume, acceleration, etc. Starting with the area and volume, right? Let's put like that, etc. Units of area is meter square, units of volume is cubic meter, velocity is meter per second, acceleration is meters per second square, etc. And no, let's not forget the speed as well, right? The speed here, I forgot to put distance traveled. Distance traveled. Okay. Note that the length is a scalar quantity. Distance traveled is a scalar quantity, but position and displacement, they are vectorial quantities, right? And yet they may have the same unit. Time is a scalar quantity, mass is a scalar quantity. And then here we have something similar. Here you go ahead. Area is a scalar quantity, volume is a scalar quantity, velocity is a vectorial quantity, speed is a scalar, acceleration is a vectorial quantity. That's what we have for the units, right? And role of units in problem solving, units are useful to help us determine whether we made a mistake along our derivations or not, okay? So that's what we use dimensional analysis for that. Okay, we use dimensional analysis for that. We analyze what is the final unit of our equations to find out if the resulting unit is the expected one, right? If I make a derivation for velocity, and then at the end I do my dimensional analysis and I get only meter at the end, most likely we forget to divide by time, right? Example, right? Example. Suppose, here you go. But that's a very simple example. There can be more complicated examples, right? Suppose you are suppose you are solving a problem. You are solving a problem in which you are expected to get a velocity. Then you perform dimensional analysis in your equation and determine that the final equation, right, has units of meter, right? This means that somewhere in your derivation, you made a mistake. Okay? So that's one of the possible applications of dimensional analysis. Okay, role of unit. Okay, trigonometry is a prerequisite for this course, right? We start talking about scalars and vectors. Okay, scalars versus vectors. Scalars versus vectors. Scalars have only a number attached to it. Okay, vectors as a number and a direction Okay, that's and the representation of vectors. And vectors are represented by a narrow. Here you go. The mathematical entity that has magnitude and direction. Right, here you go. Here's a representation of vectors. Here's another representation of vectors. That's a graphical representation of vectors. This is a graphical representation of vectors. Together is a mathematical representation for vectors. To differentiate a vector, the mathematical representation for vectors from a scalar representation, okay, we put an arrow there at the top. If this letter comes with no arrow there at the top, it means that it's going to be interpreted as though as this quantity is a scalar, not a vector. Okay, so here we go. So mathematical representation. Oh. Mathematical representation. Okay. A representation of a scalar. Representation of a scalar. And by the way, the scalar can be positive or negative, which can be positive or negative, and even complex, right? And even positive, negative, or complex, right? Here you go, representation. Representation of a scalar, A, which can be positive, negative, or complex. Can be a variable too, right? Complex can be a variable, a function, etc. Now, representation of a vector. Now I'm going to insert here equation here. I already have my A here, which can be well, not necessarily negative, right? Positive or negative, but it can also be a complex vector, can be a variable vector, can be a function. A vectorial function can be that too, okay? But the difference being that it has a direction as well. Okay. Okay, go the angle with respect to a given direction, can be the horizontal direction or the vertical direction, documents the direction of the vector, and that's what I have right in here, the horizontal direction and the angle that it makes with the horizontal direction. Okay, the length of the vector is of the arrow represents the magnitude of the vector. Those two vectors, despite the fact that I gave them two different names, they are exactly the same. In order for them to be the same, exactly the same, in order to have this equality here, the length of this vector must be the same length as this one, and their angle with the horizontal must be the same as well. Okay, that's what, and we can have two vectors, one longer than the other with the same direction, and they're still different. Although they have the same direction, they're still different because they have different magnitudes, okay? In this specific case, the magnitude of this vector is greater than the magnitude of the other vector, okay? And don't forget, the magnitude of a vector is a scalar. The magnitude of a vector is a scalar, right? Here you go, different vectors. One vector multiplied by a negative number, this guy here. Okay, I invert the direction. When I multiply it by a negative number, I invert the direction. All those vectors are different, including this one here, the negative of the other one. Vectors can be multiplied by scalar and can be divided by scalar as well. When you multiply the vector by a scalar greater than 1, it becomes longer. The magnitude increases. The magnitude of the vector increases. When you multiply the vector by a scalar less than 1, the magnitude decreases, but not the direction. Same thing all the way around. If you divide, right? If you divide by a number greater than 1, the vector shrinks in size. If you divide by a number less than 1, the vector increases in size. Okay, so here you go. Here's a vector, and here's an examples, right? Of the vector being divided by a number and multiplied by a scalar, by another number. Okay. Effectively, when you multiply the vector by a negative number, effectively you are adding 180 degrees to the direction of the vector. Theta plus pi, right? If you have a theta angle right in here and multiply this vector by -1, then you are adding 180 degrees to the original angle of the vector. Okay, here's a representation of a 3D vector. A vector in a 3D space. Okay, and we can also operate with vectors. We can sum vectors, right? Here I'm summing the same vector with itself. It's the same as multiplying by scalar 2. Okay, and what we do, we put these two vectors in evidence, right? We factor those two vectors, and then we get 1 plus 1. That's why it happens. Okay, here you go. There is one method, is the head to tail method. There are two methods, two graphical methods, right? Let's write that down here. Vectors. And we have a good summary, right? Let's on vectors. Oh yeah, here you go. Summary of vectors. I'm gonna copy and paste those. Here you go. Graphical and mathematical, right? Scalar multiplication with vectors, scalar division with vectors, vectorial summation, and vectorial subtraction. Those are the allowed operations with vectors. For the sake of this course, you can believe that. Later on, if you continue your study, you're going to see that there will be other operations with vectors that we can make, okay? But for this, only four operations for now. What are the operations that are not allowed? The regular multiplication. The same multiplication that you do between numbers, you do not do with vectors. Regular division between vectors. You cannot divide one vector by another. I'm going to make it even better than that. Yeah, better, right? Regular division between vectors. You cannot divide a scalar by a vector either. Oh, not here. Yeah, cannot divide a scalar by a vector. And there are two graphical techniques to sum and subtract vectors: the head-to-tail method and the parallelogram method. I would say that the head-to-tail method is the most useful one. Why is it the most useful one? That's because you cannot do the parallelogram with this type of vectors, right? The vectors that are collinear with each other. You cannot apply the parallelogram method with those two vectors. That's why I prefer the head-to-tail method. But sometimes the parallelogram method is best suited. Okay. Then here you go. That's how we sum those two vectors. I put the head to tail, and then I connect the tail of the vector to the last tail. The tail of one vector to the head of the other vector, right? So let's write it down. Head to tail method. Head to tail method. I'm going to describe it for you, okay? Place the tail of one vector at the head of the other. I'm even going to, like that. Place the tail of one vector at the head of the other. Two and two. Connect the tail. Okay. Let's see. Instead of connect, draw another vector draw the resulting vector, right? Draw the resulting vector from the tail of one of the vectors to the head of the other vector, right? Place the tail of one vector to the head of the other, right? To the head of the other. That's the head to tail method. Draw the resulting vector from the tail of one of the vectors to the head of the other vector. Okay? In the parallelogram method, how is the parallelogram method? Okay, place the two vectors tail to tail. See the difference between one and the other? The first step here is different from the first step here, right? Place the two vectors tail to tail. Okay? Draw a third vector parallel to the first one and place its tail at the head of the second one, of the second vector, right? Draw a third vector parallel to the, let's see, duplicate, right? Duplicate the first vector, right? The first vector, and place it, place its tail at the head of the second vector. Now you have three vectors. Now you have three vectors, right? And then what do you do next? Duplicate the second vector and place its tail at the head of the first vector. Now you have four vectors forming a parallelogram. Okay? And that's all illustrated here. Because, let's see, that's the head to tail method. Okay, parallelogram method. vectors A and B. Place the two vectors. Yeah, here you go. Vector A. I'm going to go even, come up with more. Okay, consider the vector A and vector B, right? We're going to use the parallelogram method now. Parallelogram method. Let's write it down here. Parallelogram method. Parallelogram method. First step, vector A, vector B. Place them tail to tail, right? And I'm going to do an intermediate step here. Two students coming in, okay. I'm going to do an intermediate step here, right? We duplicate, let's say this one is the first vector. Duplicate the first vector and put its tail next. That's more, let's say the A is the first vector, right? More natural to say that the A is the first vector. Duplicate the first vector and place its tail at the head of the second vector, right? Then duplicate the second vector and place its tail at the head of the first vector. Here you go. That's the B duplicated and the tail at the head of the second vector. And then the final step, draw the resulting vector from the tail of going from the tail of the two initial vectors to the head of the other two vectors in the parallelogram. Okay. So that's the last step. Okay. Draw the resulting vector from the tails of the two original vectors to the head of the duplicated vectors. Okay, that's a very good description of how the parallelogram method is done. Okay. The magnitude of the summation between the two vectors can be obtained using the cosine law, right? Do you remember? Did you memorize the cosine law already? Okay, so let's see if I have it here. Cosine law, let's go get it. It has a negative sign there, right? Oh yeah, here you go. And I want the drawing too. It doesn't look like I have the drawing here, unfortunately. Yeah, here you go. Okay, here's the cosine law. Okay. The resulting vector, the magnitude of the resulting vector squared is equal to the magnitude of the first vector squared, minus 2ab cosine of the angle opposite to the vector itself, right? Then I do have a drawing here. Let's see. Yeah, I have a drawing here. And I will copy that, put the notes. The only problem about copying those things and putting in the notes is that it becomes very heavy. It becomes very difficult to open, very difficult to load. Okay, that would be this one here. Right? And then I must have the same illustration for the other ones, right? Here's the triangle, right? I'm not illustrating the vectors, but just the sides of the triangle. Let's see here. Here are the special cases for gamma equal to 90 degrees, okay? And gamma equal to 0 degrees, gamma equal to 180 degrees. What about the other? Oh yeah, here you go. This is one that I want. Okay, I'm calling the magnitude of B as being the lowercase b, and and lowercase a and lowercase c. And here we have the opposite angle. That's the angle alpha, or angle opposite to this side. Letter A, side A, angle alpha, right? A is the Latin letter, alpha is its corresponding Greek letter. By the same token, the other one, gamma, is the corresponding Greek letter for C. And let's go get it. The C. And then we have the other triangle, beta, opposite to the side B. Okay. For practice sake, comma, reduce the cosine law for angles, the cosine law equation for angles equal to 0, 90, and 180 degrees, right? And I did that in class. Okay. That what you're, and then we have the last thing that we have for vectors. I would say is the most powerful technique. We left the best for last, right? Okay, 6, yeah, 5, 6. Components of a vector. Components of a vector. And when I mean components of a vector, I mean the Cartesian components of a vector, okay? Cartesian components of a vector. That's the first type of component, vector component that we study, the Cartesian components of a vector. The Cartesian components of a vector, components, I'm gonna put it here. Components parallel to the X, Y, and z-axis, right? If we are dealing with the three-dimensional space. If you're dealing with the two-dimensional space, let's put it this way, parallel to the x and y axis in the case of a two-dimensional vector. Components parallel to the x and y axis in the case of two-dimensional vectors, and okay. And I'm gonna copy this one here. And components parallel x, y, and z axis in the case of a vector in the three-dimensional space of a vector in a three-dimensional space in the three-dimensional space. And what do I mean by components parallel? I mean the projection, right? The projection of the vector. That's what I mean parallel to. The projection of the vector. And we do have examples here. Oh, here it's subtraction of the vectors, okay, parallelogram method. Okay, here you go. So suppose that we have this vector A, right? It has an x component and a y component. And how do you do? You project this vector along those two axes, and this angle here must be 90 degrees. The projection of the vector itself must make an angle of 90 degrees with the respective axis. Okay, let's write it down. The 90-degree projection, the 90 degrees projection of the vector along a particular axis. Okay, particular axis. That's a good way of particular axis. In other words, the projected line makes an angle of 90 degrees. Okay, here is the projected line and makes an angle of 90 degrees. Okay, so let's see. Cartesian components of a vector, right? I said Cartesian components of a vector because we had other types of components too, okay? And you have already seen this other type of projection in chapter 3, which is not going to show up in the exam, by the way. When I was talking about the acceleration, right? Let's go there so you can understand why I am emphasizing that it's the Cartesian component. I'm emphasizing that it's Cartesian component because there are other types of components too, okay? Just for you to have an idea, here you go, in this, the case of the acceleration, for instance, right? When I was doing the acceleration for you, you already see that the velocity is always tangential to the path, right? That can be said to be another type of components, okay? So you can also define, in addition to the Cartesian axis, you can also define, let's say, a tangential axis and a normal axis to this path. This would be another way of defining directions, okay? In both cases, the the new axis are going to be 90 degrees. Okay, right in here, let's see. We have this one that I want to show you. Okay, do you notice that we have the tangential? We have here a tangential component of my acceleration, right? And you also have a normal component of the acceleration. The normal component of the acceleration makes an angle of 90 degrees with the tangential component of acceleration. Okay, that's another way to look at the coordinate systems. Coordinate systems, right? The Cartesian axis is a coordinate system, and there are other coordinate systems like the cylindrical coordinate system, the spherical coordinate system. But here in this course, I'm going to stick just to those two: the Cartesian coordinate system and the tangential and normal coordinate system. Okay. That's any question. Let me see if I'm missing any questions from you. No, I am not. Let's see. Let me adjust my clock here as well. Good. Here you go. AX, AY, right? The components along the Cartesian coordinate system. Here you go. And we see the parallelogram method here, right? Here is the x component of the vector. Here is the x component of the vector. And those components, they make up we have here a parallelogram. And in this specific case, the parallelogram is exactly a rectangle. So the Cartesian components makes up a rectangular system, right? Not the most generic parallelogram method, but is a more specific, let's say, rectangular method. I'll call that a rectangular method, which is just a special case of the parallelogram method. More. And then there's another way of, a more generic way of specifying those components. Instead of writing them as a vector along the x direction, instead I write them in terms of a unit vector along the x-axis and a unit vector along the y-axis. Okay, most books use this notation. Okay, ij for the unit vector along the x direction, j for the unit vector along the y direction. But I think it's better to use this one here. Okay, and by the way, this is the type of notation that we use in more advanced courses. I still don't understand why they don't introduce this notation right at the undergraduate level. I still don't understand it. Right? It happened to me. Okay, when I was an undergraduate student, they kept introducing us to this notation, right? As an undergraduate student, and then when I went to graduate school, they replaced this notation here, that less intuitive, right, with the more intuitive notation that is this one. You can choose whichever notation you use. Okay, you can choose by yourself. Here you go. Here's an example, numeric example, right? Here you go. The vector along the x direction, let's say, is 2 meters in the x hat direction, right? The component of this vector along the x direction is 2 meters times the x hat direction. And this other component is 3 meters times the y hat direction. And now you can do the Pythagorean theorem to find out what would be the length of this vector, right? It's 4 plus 9. 4 plus 9 is 13. Square root of 13. That would be the magnitude of this vector here, and right here. And when we do is the units, when we perform the dimensional analysis, you find that the magnitude will have a length of, in terms of meters, okay? And I'm going to do, let's see if I can do that. Yeah, let's see if we have space to do all of that here. What I want to do is just to show you. Here you go. I'm going to, nope, not this one. Not this one. Yeah, 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 yeah. I'm going to do the intermediary step here. I want this. Interesting. Let's see if, yeah, okay, he did it right. That's good. So it would be 2 meters here. Okay, good. And would be 3 meters here. Okay, that's the intermediary step. Okay, and when you do that, here you go. Here's ax squared, ay squared. Okay. Next, the b vector, same thing, right? We want to sum the two vectors. Now we have a more straightforward mathematical way of finding out the resulting vector. And it is, and I can express it mathematically. Let's see. I'm going to write it down like that. Consider the b vector as being equal to b sub x in the x hat direction plus the b sub y in the y hat direction. Okay? Breaking down the vectors into its components. So here we go. Ax plus plus b plus ay. Okay. And now, from this specific relation, we can also no. Yeah. Let's see. No. Okay, I gotta do it the long way. There must be a keystroke here to get the magnitude here, but I am not finding it right now. Right, and then this we get from the Pythagorean theorem, okay? It's no longer a vector here that goes here on the right side, but it's going to be a scalar. Nope. Let's do it again. A x square, and then we repeat for ay square. The component, let's see, well, no, we do not need the square here inside. Yeah, let's try it again. Here you go. I already have the square on the outside. Right, here you go. If the vector has a z component, right? Z component, we add the z component here. And the same thing for the b vector, right? Let's add the z component here for the b vector. Z, Z, and all I have to do is to change from A to B. B, B, and B. Okay? If we sum those two vectors, A plus B, we sum their components as well, which is going to be a mathematical, which is going to be a straightforward mathematical addition. B, okay? And I'm just going to put the final result here so you don't struggle with that. Bx, right? By and Bz. Another student coming in. Yeah, okay. And if you want to get the A plus B, the magnitude of A plus B, what do? You get AX plus BX squared, AY. And by the way, all those numbers can be either positive or negative, okay? All those components can be either positive or negative. Okay? Etc. That's what we have for the vectors. And let's talk about the one-dimensional motion, right? Okay, so one, we start with position, 1D, right? You go 1D motion in 1D motion, one-dimensional motion. In order to describe motion, we have to start with the position, with the following definition. Position. Because it's one-dimensional motion, this is not going to be vectorial kinematics, but it's going to be more like scalar kinematics. There you go. With the definition of position. Position X. I denoted for. Then primary with the primary definition, right? The primary definition of position X. Then we define a secondary. We come up with a secondary definition. With the secondary definition of displacement delta x. Okay. Displacement. And then go for the tertiary definition of average velocity. Average velocity, V. Do you remember that? The definition is going to be delta x over delta t. Okay. And here is delta x is x naught and x final minus x initial. which I simplify as being x minus x naught. All right, and here we go. And then we have the instantaneous velocity. Instantaneous velocity. Oh, by the way, this one, forgot to put the subscript here, right? IVG for average. Then you have the instantaneous velocity V, which is defined in terms of a limit. And finally, we have, right, the average. I'm going to use this one here. Here you go. The average acceleration. Average acceleration. Those are all important definitions, and for a very good reason. Delta V over delta T. And finally, one more, instantaneous acceleration. Instantaneous acceleration A. Defined in terms of a limit. Okay. Defined in terms of a limit. That's what we have here. So we cover all those three sections, right? Ideally, you should memorizing all those equations here. But if you don't memorize, it's okay. Take some time to memorize, everything. But you have to work, several problems. And now, what else you have to do? Here you go. So we cover those three, right? Now we have to go into the equations of kinematics. First for constant velocity, and then for constant acceleration, okay? So uniform motion. Equation, for uniform motion. For uniform motion. And uniform motion is defined as constant velocity. Go. Constant velocity, I will place here, go, V equal to constant. Then we go back to this definition of constant of average velocity, going back to the definition of average velocity. Oh, I hate that. Okay, here you go. AVG is delta X over delta over delta T. But if the velocity is constant, then the average velocity is going to be equal to the instantaneous velocity. Okay? Will coincide with the instantaneous velocity. And now that we have this equation here, we can, I'm going to put the final result, the equations of motion, right? Equations of motion for uniform motion, which is the same as, here you go, the final equation solving for x, x naught plus vt. Let's not forget that for uniform motion, ooh, the acceleration is constant too, right? But it's a specific constant is equal to 0. Equations of motion for uniform motion, constant velocity. Okay, so one more here. And I want to I am struggling with this keyboard because it's terrible, this keyboard. My old keyboard, broke down and I have to buy a new one, and the new keyboard is terrible. Gotta find out a better quality keyboard so I don't have to keep on hitting it the way I'm hitting right now. Here you go. X naught is the initial position, V is the velocity, right? Now equation of motion for uniformly accelerated motion, constant acceleration. But when I mean constant acceleration, I mean different of 0. Okay, so this one is going to be constant. Okay, we still use that definition for average acceleration because the acceleration is constant all the time. The average acceleration will coincide with the instantaneous acceleration, which is delta v over delta t. I don't need this guy anymore. And now what was a linear equation in the position now becomes a linear equation in the velocity. See the difference? Right? V constant, let's see. Yeah. See here? V constant, A constant. V average, average acceleration. Linear in X, linear in V. That's what you have to memorize. But because it's a more complicated problem than the previous one, now my position is going to be a quadratic equation in t with the initial velocity here, right? Vt plus half at squared, like that. Okay. And then suppose, let me just, so you have a hang for what is happening, right? Suppose, oh gosh. Suppose we have another type of motion, another more complicated type of motion. I'm not going to give a name for it, in which the acceleration is linear in time. Okay? Suppose. So you can get the hang for how those equations are derived. And yeah. Good. One more. Suppose I define a more suppose I define a more complicated type of motion in which the acceleration is linear in time, right? In this case, there is something. In this case, we say that the jerk, okay, this is an actual name, okay? The jerk, we say that the jerk is constant, okay? So instead of having a equal to a constant, now it is the jerk J that is constant. And then we have the average jerk, okay? Because the average jerk is constant, then the average, because the jerk is constant, the average jerk is going to coincide with the instantaneous jerk, which is going to be delta A over delta T. Did you get the idea? And then my acceleration is going to have this linear equation, okay? The velocity, instantaneous velocity, is going to be V naught plus the initial acceleration, which can be 0, okay? Times half JT squared, okay? And that's you can derive it. It's possible to do that. And then finally we have the X naught that's going to be linear. Let's see here. Let's see. Yeah, we should have a V naught here. Okay. We should have a AT square here. And we should have a 1/3 JT cube. Let's make sure it's right. No, it should be 1/6 here. Sorry, it's 1/6. Okay, and that should be A naught because the acceleration is varying. Okay, did you get the idea? What's happening here? Depending on the type of motion that we are talking about, whether it's constant velocity, constant acceleration, or let's say constant jerk, which means that the acceleration is varying linearly with the jerk, the equations become a little bit more complicated. Okay. Oh, 1001, right? Let's see. So that's just for you. I'm not going to ask for that. Okay. I just want to have a feeling of what happens to the equations of motion once we go one step further. Okay. And let's see. We did that here. Applications of equations of kinematics. Okay. Free falling bodies. Important applications of the above equations. Okay. I need to turn off this thing so I don't keep on. Go. Okay, important application of the above equations. I'm going to give you some examples. A, uniform motion. Uniform motion. Okay, if you drop a pebble in a viscous fluid, pebble in a viscous fluid, okay, the pebble will reach constant velocity, also called terminal speed, after some time. Okay. Another example. If here you go, skydivers, when they jump from an airplane or a stationary balloon, right? Stationary balloon eventually reaches let's say, after some time accelerating, okay? Accelerating, eventually reach terminal speed or constant velocity due to air drag, okay? Here's the same thing, right? If you drop a pebble in a viscous fluid, eventually, let's see, you know, and right in the same way, after some time accelerating in the fluid, eventually it reaches a state of constant velocity, also called terminal speed, after some time. Two, if the other one is due to air drag, this other one is going to be due to fluid drag. Okay? Another example. Important, let's put important instead of important applications, important examples of the above equation, right? Of the above equation, uniform motion. Air hockey. Puck in air hockey table. Puck in an air hockey table. Moves with constant velocity, right? So you can practice physics there at the arcade. Okay, that's the three important examples. Uniformly accelerated motion, okay? Free fall, free falling bodies, okay? Free falling bodies, which accelerate at a rate of g, which is the surface of the earth is 9.82 meters per second square. Okay, and what else? Okay, rockets in space, far away from the Earth. Rockets in space that are being propelled by a constant force. Okay? They also accelerate uniformly. Okay, like that. 10:08 right now. So that's the review. Okay, don't forget, we're running out of time here. Okay, but here we have some examples or applications, right? Freely falling bar is just another example. And then the graphical analysis, right? Let's do the graphical analysis. Okay, graphical analysis. It's, I spelled out for you before, right? But let me, graphical analysis of these equations. Okay, I want to copy this thing and paste right here. Graphical analysis of these equations. uniform motion. V versus T. Graph V versus T. Graph V versus T. Let's put, here you go, let's slope. Now put it this way, slope. Graph V versus T. You know what? I don't even have to say uniform motion, no? Because that applies whether it's uniform motion or not. Whatever I'm writing here applies the slope. V versus T. The slope of the graph is numerical value of the slope of the graph is the instantaneous acceleration. Okay. You know what? I can do even better than that. Here you go. So even better than that. Graph V versus T. Here you go. Numerical value of the slope of the graph is the instantaneous acceleration. Area under the curve of the graph is the displacement. Can you remember that? Right? And now graph. I can go even for this one. Here you go. There's more here. Can do better than that. Still better than that. Here you go. Graph A versus T. Let's see here. I did it. Okay. Graph A versus T. Let's start with graph A versus T. Numerical, I'm not gonna put this. Numerical value of the slope of the graph is the instantaneous jerk, right? You don't have to worry about that, okay? Because we're not talking about this type of motion. Instantaneous jerk. But area under the curve of this graph, right, is the change in velocity, delta V. It's not difficult to memorize this because it follows a pattern, okay? It's not difficult to memorize that because it follows a pattern. Graph V versus T, numerical value, the numerical value. Let's go for the numerical value of the slope of this graph is the instantaneous acceleration. Area under the curve of the graph is the displacement, delta x. Okay, graph x versus t. Okay. The numerical value of the slope of this graph is the instantaneous velocity. Well, we don't have to worry about the area for this case, but the concavity of this graph, at a given instant of time tells you the sign of the acceleration, okay? No concavity, you know? Okay. Another one, no concavity, comma, zero acceleration. upwards concavity, comma, positive acceleration, downwards concavity, negative acceleration, like that. And we discussed that, right? Okay, 10:14. Let's take attendance here, and that's what is the review for the exam. How many pages do we have here? Let's say 1, 2, 3, 4, 5, 5, 6, right? That's 6 pages. Okay? Review for the exam. A little bit less than 6 pages. Review for the exam. Okay, review for the exam like that. Don't forget, you don't have to worry about constant jerk. Okay, this is not going to show up in the exam. But it's just for you to have a feeling of what happens to the equations of motion when we have those quantities, right? And now we can go ahead and take attendance. Today is the 25th. Oh, yeah, it's the lab. Now, 9:18, yeah, good. Let's go here. That's why. Now, let's see, what is the format of the exam? Oh, yeah, what's the format of the exam? Yeah, good point. Let me, exam format. Oh, yes, I will post these notes in Canvas, but it's gonna be here in the notes, okay? I'll post, like I post every note there in Canvas. What's the format of the exam? Okay, exam format. 1, multiple choice questions, and 2, numerical questions. Okay, so you have practiced these type of questions in the homework, right? The numerical questions you must be within 5% of the correct numerical answer. Okay, very important. There is no partial credit, there's no partial credit for either type of question. Okay, and what else do I have to put here? That is, it should be, okay, around 20 to 25 questions. You are allowed to use your notes, book, okay, calculator, you are allowed, okay? So it can be numeric too, can be either the multiple choice questions are conceptual. Yeah, can be conceptual, can be numeric, can be equation wise too. Okay, I can, for instance, ask a question and you have to derive an equation and then you have to mark what is the proper answer. Okay, so it can be either way. Okay, so suppose I ask you to derive an equation, right? You go ahead, derive the equation, and then you choose which of the multiple choice answers there is the correct one. Okay, book, calculator, computer program. Okay, Excel. Oh, 2 hours. Yeah, good point too. I'm forgetting that, right? Uh-huh. Exam, 2 hours long. 2 hours long, right? You are allowed to use your notebook, calculator, Excel spreadsheet. And by the way, I didn't have time to cover that here, right? But whatever we did in the lab is also going to show up in the exam, okay? Multiple choice questions, numerical questions, material for chapters 1 and 2, plus the concepts, plus questions about the lab, right? And what I mean about the lab, resolution, right? Resolution of an instrument, resolution of an instrument. Let's see, CL. You have to know how to use the CL table. How to use the CL table. Okay. And resolution of a measurement. Let's put it this way. Resolution of a measurement. Okay, how to use the CL table. Significant figures. Significant figures of a measurement. Significant figures of a result. Right? Etc. Okay. Around 10 to 25 questions. Exam 2 are long. You're allowed to use your notes book, Excel spreadsheet. Okay. Calculator. But you are not allowed to have someone else helping you answering these questions, okay? You're not. Okay? Don't forget, you must turn on your webcam during the exam while while answering the questions of the exam. You must turn on your webcam. So you must be simultaneously logged into Canvas and this Zoom link that we use for the class meetings, right? Wow, we're doing that for 1 hour and a half already. Is that clear? Multiple choice. Here you go. The multiple choice can be conceptual, numerical, or algebraic, right? And put this way. Man, let's any more questions? Let's see if I'm missing any other questions here. So are multiple choice or conceptual? Let's see. Yeah, okay, so I guess I answered everybody, right? Let's take attendance and then have our break. So here you go. Audrey Aguilar, are you there, Audrey? Okay, thank you, Audrey. One more student, Matthew Aguirre.
I'm here. Good.
Okay, thank you, Matthew. Darius Blending.
Hi, I'm here.
Okay, Brianna Carrillo. Okay, thank you, Brianna. Let's move that to the left. Jazzy. Thank you, Jazzy. Gabrielle.
Here.
Thank you, Gabrielle. And Liliana Cortez. Liliana, let's see if Liliana is here. I don't see Liliana in my list. Let's go Juan Escalera. Let's see, Juan is here. I don't see Juan Escalera either. Is it here? Nope. Nope. Molly? Are you there, Molly? Okay, thank you. Henry Kim? Hello, Henry. I can see Henry here in my list. I'm gonna put a star. Looks like he's away from his computer. Next, Ruth Mandujano.
Here.
Thank you, Ruth. Next is Noemi Martinez. Thank you, Noemi. Next is Danae Miller. I couldn't hear you, Danae. Maybe you might want to type there in the chat. In the chat. Yeah, I cannot hear you. Your mic is on, but I cannot hear you here. Okay, thank you. Ramon Olivares.
Here, Professor.
Thank you. Next, Taylor Thorne.
I'm here.
Thank you. Next, Alexis Quijada. Alexis is not here. Yeah, Alexis is not coming. Huh? Stephanie Ramos. Okay, the Stephanie is here. Yeah, I don't see Stephanie. Next is Jeremiah Reyes. Thank you, Jeremiah. Sean Rosario.
There.
Okay, thank you. Ali Standard.
I'm here, Professor.
Thank you. Jason Street.
I'm here.
Thank you. Next is Elena Trujillo. Elena T. Are you there, Elena? Must be away from
Here.
Oh, okay, thank you. Jason Valadares.
Present.
Okay, thank you. Stephen Vahapali. Stephen. Let's see, I don't see Stephen here. Oh, yeah, okay, thank you, Stephen. Larell Williams.
Here.
Thank you. Next, Nohamin Wandimu. Thank you, Nohamin. Next is Alia Zavala. Thank you. So let's see. I have 23 students, but I have here only 19. What's going on here? Henry, are you there? Henry Kim. Want to make sure everybody get attendance here. The students only. Let's see. Yeah, let's see. Liliana Cortez, are you there, Liliana? There's a big difference, 19 for 23 for students that I missed, right, Liliana? Let's see, Juan Salvador Escalera, are you there, Juan? Escalera with E. Yeah, I don't see Juan here. Alexis, are you there, Alexis? Who was not called, by the way? Was everybody called? Stephanie Ramos? Okay, let's see. Yeah, I did everything I could have done, right? 23 students for 29 is 4 students. That's a big difference. Okay, if you haven't been called, let me know, okay? And I want to go for our break now. Break 10:30 a.m. to 10:45 a.m., right? Gotta be careful with those long meetings. Otherwise, I get too tired, right? But I will meet you in 15 minutes. See you shortly. Okay, Henry Kim announced his presence. So now we have, and I figured out what was the problem. Okay, now I have 23 students, just like we had before. Okay, so everything is now selected. Previously, those first 3 students were not selected here. That's why I was getting the incorrect counting of students. Okay, and let's. At this point in time, you should have at this point in time, you should have uploaded your spreadsheet, your group folder. And let's go through those spreadsheets, make sure you're doing everything in the right way, okay? And I want to go in real time, go through these spreadsheets in real time, make sure you're doing everything in the proper way, okay? And I'm gonna do that only once, okay? I'm going to do that only once, and for the remainder reports, I will not do it. Not do it, okay? So let's go there. Go drive. Go drive. This one here. 2024 fall. Let's see, group one. Group one, did you upload? It looks like group one upload. It's just one per group, okay? Doesn't have to be one per student, just one per group. Okay, group one. So I'm going to choose just one of those spreadsheets, and let's see, I'm going to group number. Oh, Nuhamin is there. Let's see. Hello, Nuhamin. You're there, right? Let's see. I can see that you do not have a group, Nuhamin. Do you? Let's see here. Nuhamin, Danae. Okay. Hello, Nuhamin. Okay, looks like Nuhamin is away from on the computer. Now, but here is group number 1, right? So I'm gonna download only just means, like I said, I'm not going to grade it now. I'm gonna give you another opportunity of resubmitting this lab report so you can get a good grade for the first lab report, okay? Now, let's see here. Group, and one important point here I want you to point out, okay? Make sure you name your spreadsheet just like it is in the syllabus, okay? P06 L01 G01, right? For the first lab. P06 L02 G01 for the second lab, and so on, okay? I need you to do that because I have thousands of spreadsheets in my computer. I've been doing that since 2000. I've been downloading those spreadsheets since 2014. And imagine how many those spreadsheets I have. So by using this notation here, I can organize them neatly. Okay, so here we go. So that goes for group number 1. Okay, make sure just P06. Make sure 06L01 G01. Okay, don't put your name. Okay, just put in the format that's spelled out in the syllabus. That goes for everybody. Let's see. Let's see here. I have the for Molly, right? This one I uploaded. So I'm gonna get Molly's. Henry, you get the message too, right? Here you go. And Molly, right? Make sure you put just P06, and I'm going to download that group, and let's go for group number 3. There you go. So I'm gonna write that down as I see, anything that's lab 1. First thing, right? 1, right? 1 lab report per group. 1 lab report per group. Okay, that's the first thing. 2, name this link. Can you use this link to download? What link? Oh, okay. Cannot access this right now. Yeah, I cannot access it, Molly. Okay. So would you like to upload this file to the Google Drive? Would be easier if you upload this file to the Google Drive. Okay, Molly. I'm just replying to a message that Molly sent me. Okay. Now group 3. Let's go to group 3. Let's see. Same thing here. Okay, group 3.
Professor, when I try to upload mine, it looks different than what I have on my computer.
You mean when you open the document, right?
So that's the one I tried uploading, but
Yeah.
it doesn't look anything like the one that I have on the app.
Yeah, that's normal on Google Drive. Okay, Google Drive does not display it as it is. Okay, so that's why. But it does preserve all the formats. Does preserve everything when you download it, right? Like here, let's see the group number 3, right? Let's see how it looks like. But it's normal. Yeah, you have to open it in your computer. See that? It seems to me,
Yeah, it looks
It's
like
not
a
displaying
wonky.
properly, right?
Yeah.
That's group number 3.
It's
But when I downloaded chart 1, we put chart 1 here. Yeah, here you go. When I download it to my computer, you're going to see that everything looks fine. When I download this very document, so you don't have to worry about that. Oh, didn't download yet.
I also had a question about the formula on the last step that I couldn't
Yeah.
figure out.
Okay, so
'Cause I remember you,
let me open this one first, okay? Just to prove my point, right? Here you go. And then it's not opening. What's going on here? Oops. Excel cannot do this, the other is open. Okay, so I have a dialog box here, but I didn't note. See, okay. Okay, see that? Right? So the graphs look exactly the way they're supposed to be, right? But when you try to image it in Google Drive, it changes. It's they didn't compare those graphs that you saw in the lab in the spreadsheet that I opened in my from my hard drive, right? They're
yeah.
completely different. But yeah, go ahead. What's your question?
So I remember you were saying something about you have to add an equal sign for it to actually calculate, but I've tried it and I get an error message.
Okay, so but just for you have to add the equal sign only for the CL, okay? Like this group here, see that they didn't add an equal sign. Because they didn't add an equal sign, Excel is treating all those supposed number as text, okay? So you have to do that only for CL, okay? And then I'm gonna do that here. I'm gonna add to the front. Which group are you, by the way?
Group 3.
Ah, your group 3. Okay. So let's see what's okay. Yeah. See, Excel did calculate the number. Okay. But it's showing only hashtags. Why? It's showing only hashtags because the cell is not large enough. See that? You have the actual number there. Was that the problem that you were having? See? Was that the
Yeah, but I
problem?
thought it was supposed to calculate something in the quantities.
Uh, but you have to do the equal sign only for those ones here. Okay. I'm gonna add the equal sign here. So that goes for everybody, not just for group 3. Okay. If you do not put the equal sign here, you're going to miss those questions. Okay, so here you go. Is that clear now? Or did I answer your question?
Yeah, I just got to figure out the last part, the quantities.
Okay, so here you go. Gotta add the. So every time that you have an equation, just like a numeric equation, right? 1 minus 10 to minus 6. Make sure you put the equal sign, otherwise Excel is not gonna calculate it for you. Okay. And that's what another, we're gonna make a list. Okay, name the spreadsheet and the hard copy according. No, we shouldn't talk about the hard copy. Okay, but so let's ignore the hard copy for now. Name the spreadsheet according to the syllabus. L01. No, let's see. P06, right? L01 group XX, right? Group XX. And 3 in the spreadsheet for the CLs. Make sure you put an equal sign to the left of the equation. It is, for instance, it is not enough to type 1 minus 10 to minus 6, right? It's not enough to do that. Instead, you must type. I'm gonna copy that here. With an equal sign. I'm gonna, boldface it so you can clearly see it. With the equal sign in front the numerical equation. In front of the numerical equation, okay? If you don't add the equal sign, comma, Excel will treat this quantity as a text instead of a number. Instead of a number. Okay. So, the other thing, right, that you don't have to worry that the student from group 3 mentioned, right? When you open the spreadsheet in Google Drive, you don't don't get what you see, okay? What you see is what you get, right? Google Drive still didn't get there yet. Don't get what you see, right? In order to ensure that everything will display in the way, in order to ensure that your spreadsheet, right? Your spreadsheet will display the way you want, comma. You must visualize it from a file that is in your hard drive. Okay? So those are some of the lessons that we have to worry about, right? Don't forget group 3 to name the file properly. And let's go for group 4 now. So as we go along, any mistake that I see, I will document it here, okay? Now let's see, group 4 didn't upload the spreadsheet, okay? Okay, group 4 still didn't upload your spreadsheet. That's only mine here. Okay, I will document that here. Make sure you upload your spreadsheet to Google Drive, to your Google Drive, to the group, to your group Google Drive folder. Okay, now let's go. That's group 4. Let's go group 5 now. Group 5. Okay, so we have Elena, Jason, and Jason, right? And let's pick Jason. Hold on. Same thing applies to you, Jason. Put the spreadsheet in the proper format, right? Let's see, group 6. And group 6, nobody. Okay, no spreadsheet here for group 6. Okay, so group 6, Audrey, Brianna, Ali, and Alia, I need you to upload your spreadsheets, and also group 4, Taylor, Stephanie, Jeremiah, and Sean. Oh, one more thing, right? Lab report. Lab report is due before the following lab meeting. Okay. Now one student is trying to join us. Ruth, okay. Good, so Ruth is here. Now let's look at each lab report one by one, so you can learn from everybody's mistake, right? I will rename it here for group 3. I'll rename here. Try again. Well, okay, good. And don't forget group 4 and 6, you must upload your spreadsheet. I will put a note here. No, it's not this one, it's this one here that I want. 925. Upload document, right? Okay. Nuhamin, are you there? I can see that you do not have a group. Let me know. Should be uploaded now. Okay, Brianna. Which group are you, Brianna? 6. Okay. Okay, so group 1, I'm gonna put uploaded 1, 1, 1. Yes, 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 yes. 3, 3, 3, 3. For now, I'm gonna put no, okay. And I will 5, 5, 5, 5. And let's take a look at group 6. Yeah. Okay, Brian. Okay, let's download it. And now group 6 has the files uploaded, right? And I download. Okay, so let's start as group 1. Spreadsheet for group 1. Excel can do this, but the dialog is open again. Okay. Enable editing. Good. I will display here group 1. Oh, don't forget to put your names. Did I get the right one? Yeah, it looks like this one is nobody did anything here, right? Let's see. I have this yeah. So well, okay. So what's missing here? Group 1, student names, right? And the date, group number. So here you go. Here you go. Good. So here you go. In the spreadsheet, make sure you write down your group number, student, write down in the upper left corner, right? In the table. In the upper left corner of the spreadsheet table. Make sure you write your your group number, the students who were present during the lab, and the date. Okay. So that's the first thing I see here. Okay. Okay, and okay, they put it here. That's good. And they put the units too. See that? Meter, 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 cubic meter, okay? And kilogram. If you want to make it now, if you want to make it this cubic meter look nicer, okay, you can do the following too. It's okay to do that. You are not gonna be, punished for putting M, this way. But if you want to make it look even nicer than that, you can write M3, right? Highlight the tree, right click in the tree, and now format cell. You can superscript it, okay? And now it looks exactly the way it's supposed to look, right? Don't see that the tree is italicized. I want to put a regular face there. Let's see, normal, okay? Which is regular. Oh man, this thing is in Portuguese again. Okay, now it looks better. And you need to do only once. You need to do only once because now you can copy and paste here, right? Copy and paste here. See that? Okay. You need to do that only once. So for units that require a superscript like square meter, cubic meter, etc. Font, right? Etc. You can highlight the, let's see, the character, right? Character. That will be scripted. Right click it. Highlight format and select superscript. For units that require superscript, or it also applies to subscripts, right? Subscript. Okay, subscript should be what? Subscript X1, X2, etc. And then you can highlight, you perform the same, right? The same procedure. Whether it's in Excel or Word. Fonts should be in fonts, okay, etc. You can highlight character that will be superscripted, right click it, highlight the format cell, right? Let's see where we go. Right click, format cell, highlight, select, not highlight, but select format cell. Format cell. Format cells is the plural, and select superscript. Subscript. Okay. So one more thing to keep in mind, right? So here you go. This group failed to put it in the proper number of significant figures, right? Make sure, here you go. Make sure you put your measurements and results. Make sure you display your measurement results with the proper number of significant figures. By adjusting the number of decimal the number of decimals. Okay. I'm gonna do that just one here for you folks. Group number 1. Okay, here you go. This is a measurement with the ruler. I know that with the measurement with the ruler, you have to display 3 decimal places in the proper format, right? 3 decimal places in the proper format. Here you go. I'm even going to write it down. Hey, for the ruler, I know that I must display my measurements with 3 decimal places them in the numerical format. So you must what? First, you must convert the format to numeric. Okay, so here you go. Right click, format cell, number. See that? You have a number tab here. Alignment, font, border, fill, protect. You want the number. It is always in scientific. At the beginning, it's all the numbers are always in scientific. I do that on purpose, so you can work on that. Okay. Let me just write it down. Okay. For the make sure you display your measurement and results with the proper number of things confused by adjusting the number of decimals. Okay. For every spreadsheet you are given, these numbers will always be in scientific format. Okay. So you must do the following. For the ruler, we do know that the measurement must be displayed with for the rule, let's see. So you must do the following. First, okay, convert the format. From scientific to numeric. Okay, that's what you're going to do. You know, scientific to number. From scientific instead of let me write that. From scientific to number. Here you go. Click it. Okay. Note, see that there is no decimal place here, right? That's why it's showing 0. So, and next, display the number with the proper number, display the figure, right? The proper number of decimal places. In this case, you have to display up to the 3rd decimal place because It's the ruler, okay? There you go. Now we have the number with the proper number of significant figures. Okay? Okay, next. Next, display the measurement with the proper number of decimal places. Okay? For the ruler, the proper number is 3. The proper number of decimal places depend on the instrument used, right? Here you go. For the ruler is 3 decimal places. For the vernier caliper is 4 decimal places. For the micrometer is 5 decimal places. And here you go. For the scale is also 5 decimal places. Okay. So here is the script, not step by step what you should do, right? And that's for, let me close this one here, save, too many windows opened. Okay, so that's for group 1. Is there anything else here? Okay, the graph. Do not connect the graph with straight lines, okay? So most likely you use that format, that graph format. Let me see, let me plot that and they plot the right values. You go. But you choose the wrong insert graph. Yeah, go. Chart. Why these lines? Interesting. Why these lines are? I do not know how you got those lines, but you're supposed to have choosing this one, right? And then add the trend line only. I do not know how you got, right? Display. I do not know how you got this broken line here, one connecting the other. I do not know. Okay, and then you got this, and I do not see, okay, another problem with this graph. Okay, another problem with this graph is I don't see the R square nor the regression equation, right? Okay, make sure, let's write it down. Make sure for the graphs, significant figures. Okay, for the graphs, 1. Do not connect the data points with straight lines. Okay, that's the first thing you should know. Instead, let Excel set the best average linear straight line. Okay, that best fit the data points, right? Data points. So this black line is okay, but it looks like is what is not okay is this dotted line here connecting the data points. Okay. Okay, here you go. Now this one is also okay. There's no line connecting the data points. What about the others? I see, okay, there are graphs missing here. Okay. Group number 1, there are 2 graphs missing here. Missing graphs. missing graphs, right? There must be a total of 3 graphs. What else is missing there? It's all there in the spreadsheet, no, in the syllabus, right? Yeah, make sure you label the axis with their respective units, right? So in the case of x-axis, right? In the case of the x-axis, we must have V for volume, open parenthesis, cubic meter. And we go, let's see, font, upper script. In the case of the y-axis, you must have m for the mass, parenthesis, kilogram. Okay. Okay. Let's see here. When I uploaded the graph and data changed to what originally had. Okay. Okay. So we're looking at group 1, right? And there are other things missing here, right? You gotta come up with the R squared, the number of data points, the equation, right? Okay, you do have, 12%, that's good. That's the unit, that's the proper unit, and that's the unit 2. For some reason, it is stricken out. It shouldn't be, okay, because it strikes through, see that? So watch out for that. Sometimes there are these little inconveniences here. I do not know why we had a stricken out value there. So that's group 1. Let's move on to the next group. I'm trying to do as much as I can here, so everybody get a fair shot at improving their lab report. Right, group number 2, you uploaded a new spreadsheet. Is that right, group number 2? Group number 2, let's see.
It should be the one that you downloaded.
This one here? Yeah.
I think you already downloaded the.
Already downloaded? Okay.
Yeah.
Okay, so let's go this one here. Group number 2. Enable editing. Okay, good. We have everything here, right? The graph, okay. Yeah, make sure you put a larger font, okay? I like 12 looks a little bit small. So let's write that down too, you know. Missing graph, make sure to label the axis with their respective units. Use bold-faced font, at least 14 size, right? And okay, that's good. We have the equations here, no problem. And here, good. 3 decimal places, 4 decimal places. This one has only 3. See that? So you're missing 1 significant figure for this measurement here. So watch out that, and then you gotta do the same here. Let's see. You have 2 here, good. You're supposed to have 3 here. Okay, here you have 4 decimal places, 3 significant figures. Here you must have 3 significant figures. You have only 2. Okay, and here you put only 3 significant figures. You must have 4 significant figures. Okay. Okay, so depending on the numeric value, the number of significant figures will not necessarily be the same as the number of decimal places. And here you go. scale, the math of the scale. You gotta use 5 decimal places here for the scale. Okay, you have only 4. Okay, group 2. Write that down. Okay, and it's written right in here, right? Do not, for the ruler, use 3 decimal places. For the vernier caliper, use 4 decimal places. Don't forget in number format, right? First, put it converted to number format. Micrometer, 5 decimal places. The scale, 5 decimal places. Don't forget, note, the number of decimal places is not necessarily the same as the number of significant figures. Okay? And okay, okay, so you put the CL in the proper format. I do not know if those, oops, I do not know if those are the correct values, okay, because I don't have the table here to check. But look here, okay, slope. Okay, that's good. Yeah, percentage. Remember the other spreadsheet had this strikes through here. It looks like it's from the original file that I used. Okay, so make sure to uncheck the strikes through in your. So those, and you have the units here. You have the units here, right? Good. And again, if you want to place in a nicer format, so you can see the cube there at the top, superscripted, you can do that too. Okay? Because those numbers are less than 10 to minus 3, right? They kept the format, they kept the scientific format. That's good. It's easier to read a number like that than to read a number with several zeros to the right. It's just too much, right? 0.00, like this other one, 1, 2, 3, 4, 5, right? 5, 6, right? It's much difficult to read this number here than this number here. Let's see if I'm right. Oops, that I gotta reformat it here. Number, 1, 2, 3, 4, 5, 6, right? So here you go. Let's see if I put the right number of decimal place there. 1, 2, 3, 4, 5. Oh, there's 1. Okay, so there must be another 0 here. 1, 2, 3, 4, 5, 6, right? It's much difficult to read this number than the other one that we saw. Let me increase the size too. Size, format. Yeah, here you go. Oh, format. And I gotta put, is that 7 decimal place? Yeah, let me see. Can you show what the micrometer value should look like with the correct decimal places? Micrometer, yeah, here you go. You're talking about the volume, right? I fixed the graph. Okay, here we have 1, 2, 3, 4 significant figures, okay? 5 decimal places, but 4 significant figures. And here you have only 3 significant figures. How it should look like? Right click, format cell, add 1 more decimal place. Now you have 4. See there, 1, 2, 3 decimal places plus 1 regular number. Now you have the right number of significant figures, okay? I did just for this one, now you do for the rest. Okay? Group 4 uploaded our report. Okay, did I download it? Let's go to group 3 now, right? I didn't download the group 4 yet. Let's go to group 4, 1135. Here we go. Is that the one here? 1104 should be this one, right? Yeah. Let's download it. Okay, I'm gonna get the latest one, okay? Download, good. Now let's go to group number, see, group number 3 now. What's going on here? Okay, enable editing.
I uploaded a new one right now with
Which
the
group are you?
group 3.
Okay, so let me close this one.
I did the sig fix.
You go group 3. This one here? No, this one here.
Yeah.
Right. Yeah, make sure you put in the proper format, okay? So download it. Group 3. Group 2, let me close. Did it download already? Yes. Let's see, group 3. I will copy this one and I will delete it. And now I'm going to paste here. Group 3. Right? Okay, so let's see what's going on. Okay. 3 decimal place, 4 decimal place, 5 decimal place. That's good. Let's see. Did you put? Okay, you gotta put the names of your groups of the students, right? Oh, another important note. Okay, I want to make here because I didn't write it down. Very, very, very important. Make sure you upload your spreadsheet. Okay. And it's so important that I'm gonna put here at the very top. You go. Make sure you do not copy or do not change the positions of the tables. Okay. When I correct those spreadsheets, I corrected using a program, and the program assumes that you didn't move the tables around. Okay. In the spreadsheet. Okay. In other words, do not change the position of the table. Do not delete lines and columns, okay? In the spreadsheet, keep the original. In other words, keep the original positions of the cells. Okay? Very, very, very important. Okay, so here you go. We have group 3. You know, you should have more students here, right? And the date. And okay, we have here the graphs. Okay, it's not gram per cubic centimeter, okay? We are not using grams per cubic centimeter. We are using kilograms per cubic meter.
Yeah,
Okay?
sorry, I just noticed that.
Yeah, so here you go. Let's write it down here. Oh, and it's not, and remember, this unit here is not the unit of volume, right? This unit here that you wrote down is the unit of, what's the unit that you wrote that down here?
Mass.
This is the unit of density, right?
Density.
So 2 mistakes here, right? You put the unit of density on the top of that. You didn't use the SI units, right? So let's write that down here for the graphs. I'm not going to write that down. I'm not going to write that down. Let's and ruler. Okay, R square. You have the good. Yeah, you know, just like before, right? See, there's so many zeros here. It's difficult to read, right? So let's write that down. For numbers, for numbers less for numbers less than 0.001, use scientific format. Okay, so it's easier to read. For number less than 1,000 and okay.
And how do you want us to switch that back?
Well, it's here you go. You double click here, right? Double click in the axis, and now you have all those panes. Okay, so let's look at this one first. See that tick mark, labels, number. Let's see what this one have, right? See that? It's numeric format, right? So now you go in this arrow and you click, you select scientific. Okay. Oh, what's happening? Yeah, but then you look how many decimal places I have here. They are encroaching on each other, right? There are so many decimal places that they are encroaching on each other. You know, you can use 2 decimal places in this case. Okay. And maybe 2 decimal places even too much because those numbers are 0.0. So you can use just one. Here you go. Make
Got
sense?
it. Yeah, I got it. Thank you.
Okay. So here's the same thing, right? Numbers encroached on each other. And let's see, what about the formats? Okay, you put the units, that's good. Oh, again, you gotta have 5 decimal places here, right? 1, 2, 3, 4, 5, right? And those you can put in scientific format, but note, see, you have 2 significant figures here. You're supposed to have 2 significant figures here, right? You have 3 significant figures here. You're supposed to have 3 significant figures here. You put 4, 3, 4, and 5, right? You're supposed to have 4 significant figures, right? 4 significant figures, 5 decimal places. You are supposed to have 4 significant figures here. Now, let me see. This one here is an odd one. Let's see here. Why it has interesting. Okay, so you gotta put 4 significant here. Yeah, you put 4 significant figures here. That one is just this one. This one is okay. The only problem are those ones here. You put too many significant figures. Okay, just to confirm, do you want us to have 5 sig figs for or 5 decimal places for the scale? Okay, depends on your. Okay, here you go. For the you mean for the graph here? Or, for the scale, you have to have 5 decimal places for the scale. 5 decimal places for the scale, not necessarily 5 significant figures, okay? And that's what I wrote there, right? Let's see here. Note 5 decimal places. See that? I wrote 5 decimal places. I didn't write the 5 significant figures. Okay. 1144. Let's see if there is one more thing here. Okay, so it looks like you put the number. Again, I do not know if those numbers are correct, okay, because I didn't consult the table, but I have a computer program that's going to correct that for me when I do that. And you forgot to put the slope, right? Make sure, let's see. Make sure you type the slope in the last table. Okay? Make sure you type the slope in the last table. The slope, you do not have to worry about significant figures for those quantities in red, okay? Because it would be too complicated to find out the right number of significant figures for the slope. Oh, you forgot the units, right? Don't forget the units. Make sure don't forget the units. Don't forget the units. I take out points for the units, take out points for incorrect units, right? Take out points for incorrect significant figures. That's group number 3. Let's go to group number 4. 14 more minutes to go. Do I have anything else? Yeah. Good. So let's close this one. Now we should go to the next one, number 4, group 4. Okay, so here we go. I see, okay. I see the group number, okay. Date, and now it's all the way around, okay? Okay, we swap it. Here the labels. It's mass in the vertical. And let me enable the editing first. Mass in the vertical. Let's see. Oh, yeah, that's right. You gotta put the mass in the vertical and the volume in the horizontal, okay? Do you see that your slope here is a negative exponent? Okay, so definitely it's not going to match this value here. If you type the slope that you got there, see, you're getting 99%. That's because you plotted the graph in the incorrect way, right? I do not know how, let's see. The proper way to do that is volume here and mass, insert. Okay, here go, right click, add trend line, display equation on chart. And now what do I get? See, now I get the proper number, right? 8,092.5. So 8,092.5, now I get only 2% of 2.5% of difference with that number, which is the inverse of the slope, right? It's the inverse of the slope that you wrote that down here because you plot the volume on the vertical and the mass in the horizontal. With that slope that you entered here, you're getting 99% difference, okay? And the units here of the slope is incorrect too. The unit of the slope is the unit of the vertical axis divided by the unit of the horizontal axis, which should be kilogram per cubic meter, right? Per cubic meter, like that. The unit of density, don't forget to add the unit for the percentage difference. Let's see if we have more here. Okay, you put equal sign there, that's good. 6r square, the equations. And let's see if there is any problems with we have all the units here. Let's see if there's any problem with okay, 3 decimal places, 4 decimal places, 5 decimal places. 1, 2, 3, 4, 5. Here you go. And then we should have 5 decimal places for the mass. Okay, so change it to numeric format. I do not know if this is correct. Let's see, let's do this correct. Format cell, numeric, 5 decimal places. Yeah, we have 1, 2, 3, 4, 5. 5 decimal places, but it's 4 significant figures, right? 2910 are the significant figures. So you do not have the proper number of significant figures here. And 2 significant figures here, 2 here, 3 here, 3 here, 4 here, 4 here. It looks like you're good, but not here, right? Here you have missing significant figures. Okay, that's group number 4. So he plot the graph. Okay, group 4, he plot the graph, and you'll be good. Let's go for the group number 4, group number 5. Can you show what the micro? Okay, group 5. That's group 5 here. Enable editing. Okay, put the other student's name, right, Jason? Yeah, let's see what you do here. I do not know why you have this format here. The format should be, if it's today, right? 9/25/24, right? Oops. And then you have to change the format too, okay? See that? I put the date of today and it display the number here. It should be Julian numbers. I believe what this number is a Julian calendar, which is a different calendar. So you gotta go back to the format cell, date, and then choose the proper format that you want. Okay, here you go. And then let's see, it's not centimeter, it's not millimeter, right? Everything here, every measurement that we have will be displayed in the main.
Mister, I actually updated my chart because
Group
I
5?
saw that yeah, for group 5. I sent a message to you. I didn't think you saw it.
Okay, so
Yeah.
let me get that. Let me get that. Group 5.
I'm putting in I was gonna put the names in right now, but yeah.
Is the one at the top? Which one else? I have the
Well, mine, Jason.
Jason, this one here.
Yeah, that was the one you said.
11:50. Okay, so let's download it. Download it. Okay, I'm gonna open it. Enable editing. Okay, good. So here we go. Yeah, okay, meter, cubic meter. Okay, that's good. But then you have to work on the significant figures here, right? So put everything in numeric format, and then you count the decimal places. The number of decimal places should be 3 here for the ruler, 4 for the vernier caliper, 5 for the micrometer, and 5 for the scale. And then once you have them in the proper format, once you have them with the right number of significant figures, then you go the next step. Display the proper number of significant figures of the volume for the ruler, display the proper number of significant figures for the volume of the caliper, right? You cannot get here the proper number of significant figures unless you have the right number of significant figures here. Okay, so let's see how's the graphs. Okay, the graph look good. Again, if you want to, make it look nice, right click superscript. Yeah, here you go. And you can also boldface it. So it makes it easier, so it looks easier. I also like the boldface those too, okay? I also like to boldface those. Let's see how I'm going to do that. There's a way, let's see, here you go. Axis option, tick marks, labels. No, numbers. Is that the one here, middle? No.
Would it be in text options instead? The one next
Oh
to
yeah,
axis
that's
options?
right. Text option. Good eye. Yeah. Text field. Let's see. Solid field. The text outline. Solid. Yeah. There's no format option here. Yeah, I don't see any format option here. Let's see. Maybe you right click. Oh yeah, here you go. The way you do it is you click here and then you right click font. Okay. Now we can boldface it. And don't forget at least 12 size. Right, become too small. Right? And you can do the same for those two. So don't forget, click, right click, font. Right? It's okay to leave a scientific format here because the number less than 10 to minus 3. Here, you can leave in a numeric format. And look, it's very important because you see the numbers repeating here, 2, 2, 3, 3, 4, 4, 5, 5. So you have to have at least one decimal place here in this specific format, okay? So you do not get this repeated numbering here. For the ruler volume, if we use 3 decimal places, wouldn't that equal to 4 significant figures? Let's see. Yeah, that's right, Molly. Remember, the rule for 3 decimal places applies only for the diameter. It does not apply for the volume. Okay? Okay, let's write that down. you know, is okay. The rule, here you go. This rule applies only to the diameter measurements, not to the volume, which is a result. Okay. Okay. Same thing for the others. There you go. Same thing for the others. Okay. Same thing for this one here. Right. You're not measuring the volume with the vernier caliper. You're not measuring the volume with the ruler. You're not measuring the volume with the micrometer. You're calculating the volume from those three measurements. Okay? That's why this rule doesn't apply. Now, let's see. That's group number 5, right? We're running out of time here. Let's see. Anything else? Okay. Definitely there is a mistake here. Okay? Group number 5. Definitely there's a mistake here. Okay, you gotta look there at the table, make sure you are not apparently you are not displaying the CL, you're displaying the R square that's in the table. That's what it looks like. You gotta look at the top of the table, okay? So look carefully there. Here you go, this one, 2%, 3%. Yeah, put that in numeric format so you can see better what those numbers are, right? 231, okay. Okay, so don't forget, right, to correct that. That's my significant figures here. I don't see any problems with the units. Now let's go to the last group, last but not least, right? Next time I start with group number 6, okay? So here you go, group number 6. 2 more minutes. But don't forget, here you go, group 6, blah, 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 that's good. Oh yeah, they don't have the units here, okay? Group 6, you gotta put your units here. And 3 decimal places, 4 decimal places. Okay, let's see. Okay, there's a problem here. Yeah, oh man. Okay, so I do not know where those numbers came from. I do not know if I gave you the incorrect number, but definitely there is a mistake here. I do not know. Oh, definitely, yeah, and it was, I do not, let's see. See, it's not possible that, see, there's a mistake here, okay? Most likely it was not you folks who made this mistake because I provide you the data, but the data had this problem, okay? There was an additional 0 here. And now you can put 4 decimal places. 4 decimal places, number, 3, 4, okay. Now you have the right number of significant figures. This one have to have 5 decimal places, right? This one, see that? This one is there's a mistake here. You have only 4 decimal places. So you got to add a decimal place here, okay? To get it right. And once you have the proper number of decimal places, now you can count the number of significant figures. Choose significant figures, choose significant figures. See, there is a significant figure missing here. Choose significant figures, choose significant figures, choose significant figures. This one has only 1 significant figure. So the way you display it here is correct, okay? Because you have only 1 significant figure. 2, 2, right? Here you have 3. Everything here, 3, 3, 3. Only this one has 2. So you gotta display 2 significant figures. You gotta display 3 here, 3 here. 4, everything here is 4 significant figures. 5 decimal places, 4 significant figures. You gotta display 4 significant figures here. Here you have to display 5 decimal places. Okay? 5 decimal places. That's for group 6. Let's see if there is any. We're running out of time. Let's see. You gotta put the axis, right? Label the axis. Don't forget to label the axis. Definitely you swap the axis. You put the volume here in the vertical instead of here, okay? Group 6, you made the same mistake as the other group of students did. Here you go, the volume, see that? You put the volume here instead of putting the x-axis. Then because of that, your slope is gonna give you gosh, let's see. Oh, you put kilogram here, right? That's why you gotta be careful, okay? Because you put kilogram here, it's not calculating the percentage difference. So just put the numeric value here. Because the unit is already here. The unit is already here. Okay, don't repeat the unit here in the cell. So when you display the number in the proper format, you get this huge percentage difference, right? Because your slope is the incorrect one, right? So you gotta plot the graph properly, get the slope, and place it here. And don't forget the units. You forget the CL too. Okay, make sure you put the CL here. It's 12:02 now. Any questions?
Yeah, I have one, Professor.
Yeah,
The,
who's that?
so you said it's supposed to calculate by itself, like the slope difference.
Yeah.
So I have values for the n, the m, and the r squared, but it's not calculating anything.
Are you talking about the slope or the percentage difference?
Both.
Okay, the slope you have to type manually. Okay, the slope you have to type manually, and you type exactly the slope that's here is in the equation. Okay, that's why you need the regression equation. Okay, yeah, and your group number
3.
3. So let's go there to your group number 3. Group 3. Okay. Okay, so here you go. Okay, see, that's the slope, right? All the slopes must be entered manually. Okay, all the slopes, 8,092.5, right? 8,000,
Got it. It got something now, yeah.
8,902.5. Okay, what has the equation here is going to be the percentage difference. That this one is displayed automatically. Okay, since you don't have anything here, it's calculating 100% difference, right?
Gotcha.
Okay, so that's it. So now you can correct your lab report, right? Your spreadsheet and submit again next week before the exam. Okay. So I see you Monday and have you all a nice weekend.
Thank you, Professor.
See you. Bye-bye.
Also, one last thing, Professor. Is it
Yeah.
okay if it's a low difference, like 20?
12%? Yeah, it's okay. It's okay because it's a ruler, right? If
So I got 2.4 for
for what? For the vernier caliper?
the ruler.
Oh, for the ruler. Let's see. Which one is the ruler? Let's see which one. Is this the ruler? Yeah, that's the ruler. 8092, right? 80, did I mistype it?
But I also
Oh
fixed
yeah, I
the
mistype it, 8092. Yeah, I mistype it. That's why I'm getting 12. Okay, now I'm getting 2.
oh, okay.
Yeah, I mistype it. That's why.
Okay, so that's good.
Okay.
Hi, Professor.
Oh, it's you.
All right, have a good one.
You too.
Professor, quick question.
Yeah.
For group 5, can you check how my upload looks on your end?
Group 5.
Yeah, group 5, it should be the third upload.
Yeah, here you go. This one here, right?
Let me see. No, not that one. It's for the other Jason.
Yeah, Jason's. You see, Jason's P06 L01 G05.
The other one, because there's 2 Jasons in my group.
Yeah.
Yeah,
that's
that one's mine. Sorry.
Yeah, the one
Should have
below
put
it.
my initial.
Okay, that's group 5, right? Which one do you want me to download? This one or
The one below.
this one here?
Yeah.
Ah,
just curious.
okay.
Okay.
Okay, so here go. Let's go. Let's open it. Now enable editing. Okay, so you have everything here, right?
Yeah.
7,900. 3 decimal places, 4 and 5. Do you have 5 decimal places here? No, right? You don't have 5 decimal places, so you gotta fix that, right?
Okay, so you need 5 there. Got it.
And then, you gotta fix that too, right? 3 decimal places, 2 significant figures. So you must have 2 significant figures here too.
Okay.
2, 2, 2, 2, 1, 1, right? 1, 1.
Okay.
And 3 significant figures, 3, right? 4 significant figures, 4, right?
Okay. So
Now,
under the formatting the cells, just make sure they're equal to one another, essentially.
yeah, but
Okay.
in terms of significant figures, right? And here, you don't have the regression equation, right? The regression equation is missing.
Okay.
Click, right click, add trend line, display regression equation, display R square, right?
Okay. Because it's weird because on my end, when I have the actual original document, I have all that information there, but I guess,
Really?
yeah, I don't know what's going on. So I guess
Okay.
that from there.
So are you using a Mac or a PC?
I'm using PC.
PC. Okay, so it
Yeah.
looks like something is getting lost. It doesn't get lost, from my experience.
Yeah. So I
When
have
you
to,
upload.
I gotta play with it, I guess.
Yeah. Okay. So here you go. This one here, 10 to minus 7. Okay, you gotta increase the number of decimal places, right? So
Okay.
we can see everything instead of number 1. Yeah. Okay. Now we should. And what about this one? Looks like this one is the same thing, right? You gotta increase the number of decimal places. Yeah. So it doesn't display 1 and 2. Okay, good. Okay. You put cubic meter. Okay, good. So the only problem here is that the equation is not displaying, but everything else looks fine.
Okay. So that and the significant figures for the volume?
You mean here in the graph?
No, in the
Oh, here
table.
in the table. Yeah. Yeah.
Okay.
Those 3, no? Those 4
Mhm.
columns. You got to work on the significant figure in those 4 columns.
Okay.
Okay.
Okay. Got it. Thank you.
Okay. Anybody else? Okay, so let's go.
Bye, Professor. Have a good one.
You too. Bye bye. Let's see, where is this one here? I'll stop sharing.